Hello, Golden Eagle Math Stars. This is another PowerPoint jazzed up by me. It comes originally from the book, and I've added some pieces from another website called Regents Prep from the New York State Regents exam. Let's move on. We're going to go through a little warm-up to get your heads ready. We need to write the equation of the line passing through each pair of passing points in slope-intercept form. Pause the video now, take a second to go through. This is what you will turn in as proof that you have watched the video. So you need the line that goes between the point 5, -1, 0, -3, the line that goes between the point 85, -8, 7, and the line that goes, let's see, oh wait, here we go, use the equation y equals -0.2x plus 4, find x for each given value of y. Here, in case you're rusty, we make the y equal 7 and solve for x. Sometimes we substitute for x and solve for y. Sometimes we substitute for y and solve for x. It can go both ways. I'll give you the answers at the end of the presentation. So now we have our objective. Students will determine if a scatter plot represents a correlated relation and identify the nature of that correlation. The essential question that you're going to put down on your Cornell notes: why would I want to graph my data points? I mean, if you went ahead and found them and have them in a table, isn't that good enough? And what can they tell me when I do graph them? So interpreting and understanding why. Take a minute to pause if you need to. Write these down, and then we'll move on. Here we have the vocabulary for this lesson: correlation, positive correlation, negative correlation, interpolate, and extrapolate. Interpolate and extrapolate are possibly very, very new words, so listen closely. I will tell you what they mean. All right, I'm going to give you a second. You'll pause the video, write the words in the question section of your Cornell notes, and then we'll be ready to move on. So once you have a bunch of information, have you ever been curious to know if one event affects another event? For example, if I study longer, will I get a better grade on my Regents examination or my STAR examination? This is one reason we use scatter plots. Statisticians and quality control technicians gather data to determine correlations or relationships between such events. So a correlation is a relationship between two events. So the correlation is a relationship between events. Correlation is a relationship between events. That looks like a definition to me. You may want to pause and write that down. Scatter plots will often show at a glance whether relationships exist between two sets of data. So one reason we use a scatter plot is because we're very visual animals, all of us mammals, all of us as humans, and sometimes when the numbers are in a table, they don't make any sense at all. But when we put them in a picture form, that is the picture form of a graph as an organized picture, suddenly, hey, stuff pops out that we can see. A scatter plot is helpful in understanding the form, direction, and strength of the relationship between two variables. Like I said before, when we put it in a picture form as an organized picture, suddenly we can see, hey, this is what the numbers are tending to do. Correlation is the strength and direction of the linear relationship between the two variables. So we're going to add to that definition from the first page. Okay. Again, correlation, the strength and direction of the linear relationship between the two variables. We're going to review the direction part right now. Well, the strength part. If we look at the graph of the positive correlation, positive slope, we see that if we were to circle the points, the tilt of the circle resembles a positive slope. It goes into the positive quadrant. That's where we get the positive part. Positive, positive. All right? We have 2. right next to it, we have another positive correlation, positive slope. And then over here, we have relatively no correlation. Now, if you notice, I was able to circle these with a very tight shape. Over here, the circle is kind of broad, and I could draw a line going this way, and it would kind of fit some of the points, but not these over here, not these over here. Or I could draw a line going this way, and that fits some of them, but not all of them. The tighter your circle, the better your correlation. As we go through our correlation lesson, I want you to remember we are not connecting the dots from point to point to point, but rather trying to find a single line that comes closest to the most dots possible, or to the most data points possible. Here is an example of a positive correlation expressed two ways. I should say demonstrated two ways. I'm going to draw a circle closely enclosing my data on the left. This has a high positive correlation. On the right, I still have a positive correlation, but notice the shape that I can use to enclose the highly correlated points is much smaller, narrower, tighter. It's a narrower fit. Here, the shape is, if I divide the shape in half, it's still positive, but it's a much wider shape. There's a lot more distance from the points to that line. All right. The total distance from your points to this bisecting line is what decides how well correlated they are. If it's highly correlated, these points are very close to that bisecting line. By the way, this distance here, all of these little distances will add up to what your error is. Over here, the total of the distances is farther, so it has a bigger error. Now we're going to look at negative correlation. In a negative correlation, all of your points tend to be trending down. That means that as your domain value gets larger, as you go bigger this way, your range values get smaller. I'm going to use my circle analysis again, just in general. Now we can see on the left, if we divide our circle, the points are closer. It's a narrower shape. If we look on the right, and we divide that shape in half, the points are farther apart. It's a wider shape. So these are pretty much all together closely doing the same thing. Over here on the right, they're kind of doing the same thing, but they're taking their sweet time doing it. A high correlation means your data is tightly packed and very much doing the same thing. A low correlation means your data is more spread apart and mostly doing the same thing. I forgot to tell you what it means when they are positively correlated. Positive correlation means that as your domain value gets larger, forgot to turn the pen on, sorry about that. As your domain values increase, your range values increase too. They're both doing the same thing at the same time. That makes us very happy. We are very positive because everybody is doing the same thing at the same time. When the teacher says learn, the students are learning. Yay! With a negative correlation, when your domain increases, your range decreases. It's not necessarily a bad thing. As the temperature increases, evaporation let's see, the amount of water in a cup decreases because it's evaporating. And that can be a positive thing. It depends on what you want to have happen. Negative isn't a judgment, it's a direction. Negative is not a judgment, it's a direction. All right. Now we're going to look at a situation where there is no correlation. And if you look at all of these data points, it looks like a blob. Is it going this way? Is it going this way? I don't know. I can't really tell. Some of them have a positive correlation, but then some of the others have a negative correlation. There's not really any correlation at all. Just because my domain values are increasing, see, I made that mistake myself. Just because my domain values increase, that doesn't mean my range values do anything. The range values sort of do what they want, when they want. Going back to the vocabulary to check, there are two words that I haven't covered for you. Interpolate and extrapolate. Okay. Remember I said that we make a scatter plot so we can let the data help us. When you interpolate, that's when you make your line of fit and you want it to go, whoops,